Hi, I'm Justin.
Hi, I'm Alexis.
Hi, I'm Jesse.
And our topic is limiting reactants.
The first thing we're going to be talking about is the definitions. The first definition is actual yield. The definition of actual yield is the amount of product actually produced when the chemical reaction is carried out in an experiment. The next definition is theoretical yield. The definition of theoretical yield is max amount of product that can be produced from a given amount of reactant. The next definition is percent yield. Percent yield means the ratio of actual yield to the theoretical yield expressed as a percent.
Limiting reactants. Okay, so we will start off with an example right now. So let's say you wanted to make a hot dog. So you need one bun, one weenie, and also a ketchup. Next, you will put another hot dog, bun, and then a weenie, and then a ketchup. You notice that you have a ketchup left over. This will be your excess reactant. Okay, to start off with another example, I will be using the formula Li3PO4 plus 3KCl yields to 3LiCl plus K3PO4. If I start with 37 grams of lithium phosphate and 45 grams of potassium chloride, what is my theoretical yield of lithium chloride? So, you will first be starting off with what is given, which is 37 grams of Li3PO4. So, using the periodic table and scientific calculator, you want to figure out the molar mass of Li3PO4. So on the periodic table, if you can find Li, okay, so Li is equal to 6.94. So since there is a 3, I will be multiplying that times 6.94. Then I will add that to P, which is phosphorus, which equals 3.97 plus 4 times the atomic mass of O, which is oxygen, which equals 16, equals 115.79. So now you will put 115.79 grams of Li3PO4. So since this is grams of Li3PO4, this would be equal to 1 mole of Li3PO4. So since you have 1 mole Li3PO4, you want to cancel that out. So in order to do that, you put 1 mole Li3PO4 down here. Okay, so now you have mole down here, and now you're going to put mole up here. So instead of lithium phosphate, you want to change it to lithium chloride, which will be LiCl. And when it's mole and mole, you have to look at the coefficients, and this is why I underlined it in purple. And since there is a 3 in front of LiCl, you're going to put 3 up here. So once again, you have mole up here, and you want to cancel that out. So you're going to put 1 mole of LiCl. So up here, you want to convert it to grams of LiCl. So now on the periodic table, you will look for Li, which is 6.94 plus Cl, which is equal to 35.45. That would equal to 42.39 grams of LiCl. Now you want to calculate that and multiply 37 times 1 times 3 times 42.39, which equals 4,705.29. Then you calculate the bottom, which is 115.79 times 1 times 1, which equals 115.79. If you divide 4,705.29 divided by 115.79, that gives you 40.64 grams of LiCl. Okay, so next for the second part, it is asking to start off with 45 grams of potassium chloride. So down here I have my second T-chart, and I put 45 grams of potassium chloride, also known as KCl. So move on to the periodic table, look for K, which is 39.10, plus Cl, which is 35.45, and that gives you the molar mass of 74.55 grams of KCl. And like I said before up here, when it's grams, you convert it to 1 mole of KCl. The middle part will always be mole and mole when it's a 3-step T-chart. So once you get here, you look at the coefficient again of KCl. There is a 3 in front of it, so you're gonna put 3 mole KCl. Now up here, you're gonna convert it to moles of LiCl, and the mole would be 3 because of the coefficient here. Now you want to cancel this out. So over here is going to be moles to grams. So when it's moles to grams, you put 1 mole of LiCl. And up here, you're going to convert it to grams of LiCl. So now to convert it, you're going to put Li, which is 6.94, plus Cl, which is 35.45. And that gives you 42.39 grams of LiCl. Now you're going to multiply the top, multiply the bottom, and divide that. So 45 times 1 times 3 times 42.39 gives you 5,722.65. Now you multiply the bottom, which is 74.55 times 3 times 1, which gives you 223.65. Now you divide 5,722.65 divided by 223.65. That gives you 25.58 grams of LiCl. So now you want to figure out which one you have less of, and obviously 25.58 is less than 40.64. So now you want to box 25.58 grams of LiCl, and that will be your limiting reactant. Okay, so here the question is basically asking what is the limiting reactant and what is the excess reactant. I'm just showing you that you have to use the original formula. So what is the limiting reactant? That would be KCl. And then it's asking for the excess reactant, which would be Li3PO4.
Moving on to the next example, Cn plus CuCl2 yields to ZnCl2 plus Cu. How many grams of ZnCl2 will be produced from 7 grams of Zn and 8 grams of CuCl2?
Okay, so here Jesse is just putting the molar mass of zinc, which is Zn, which is 65.39, and on top of that you put 1 mole of Zn. Then he cancels it out with 1 mole of Zn, and on top of that you're going to put the coefficient of the ZnCl2, which there is no coefficient, so it's just 1 mole. Then you cancel that out as well, which is 1 mole of ZnCl2. And on top, he's figuring out the grams of ZnCl2, which is also known as the molar mass, which comes out to be 136.29. Next, you want to multiply the top, which is 7 times 1 times 1 times 136.29, and that turns out to be 954.03. And then you want to multiply the bottom, which is 65.55 times 1 times 1, which gives you 65.55. And then you divide it, and that will give you your answer. Okay, so starting off with the next T-chart, Jessie will just start off with figuring out the molar mass of CuCl2 using a periodic table and a scientific calculator. On top of that, you just want to put the mole of CuCl2, which would just be 1 mole. Then you cancel it out once more at the bottom with 1 mole of CuCl2. When you get to the top, you put the coefficient of the formula that you're trying to transfer it to, which would be ZnCl2. In this case, there is no coefficient, so you just put 1 mole. Then you cancel that out at the bottom with 1 mole ZnCl2, and on top, you figure out the molar mass of ZnCl2, which is 136.29. As for this part, you want to calculate the top like we did on the other equation. So you do 8 times 1 times 1 times 136.29. So once you get the answer for the top, which is 1090.32, you multiply the bottom, which is 134.45 times 1, which gives you 134.45. Then you divide the top by the bottom, and that gives you your answer. The limiting reactant is CuCl2, and the excess reactant is Zn.